Okay, so the next topic is about multi-GPU acceleration for faster and or bigger wave-based simulations. So up until now, the Treble application has only leveraged one GPU per simulation, but now we offer the capability to leverage several GPUs per simulation. And this kind of handling of how many GPUs are per job is taken care of for the user, so just kind of the optimal amount of GPUs for a given job is selected automatically. Now the kind of whole science around parallel computing and all that stuff is quite complex, and I'm not going to dive into all of the details here. So it can be a bit nuanced in kind of how much performance boost one gets in what types of cases and so on. It's not just some very simple linear curve or something. But overall, I think the takeaway is that for small wave-based simulations, that's either small rooms or at low frequencies, there is actually no difference between running a single GPU versus multi-GPU. So the software will actually just select one GPU for such small jobs. Then we have a category of jobs which is sort of medium-sized jobs, you can say. These are jobs that you could run on one GPU, but leveraging more than one GPU speeds the simulation up. And then at a certain point, the simulation gets so big that one GPU cannot handle the job. It simply cannot fit all the mesh elements in the simulation into the memory of the GPU. And this is what the third category, let's say large jobs. And then you need many GPUs to be able to run such simulations. So in summary, small jobs, no difference. Medium jobs, faster now than before. Big jobs, possible now, weren't possible before. And I'm going to illustrate this with a case, which we see here on the screen. This is a sort of relatively large auditorium. It's around 18,000 cubic meters, so quite a lot of volume. And I've simulated this space sort of before and after we introduced this multi-GPU functionality. And I'll show you some performance numbers and so on, but just showing you first here that if you are in multi-GPU territory, then you are notified of this when you hit the run button here, that multi-GPU is enabled. So you are benefiting from that functionality. But let's take a look at some performance numbers for this hall here. So I'm going to switch over here. The hall has been simulated for a few different transition frequencies with and without this multi-GPU functionality. And if we first look at the kind of lower transition frequencies, this is the upper limit of the 125 Hz band, and this is the upper limit of the 250 Hz band. Then we see that multi-GPU does not actually lead to performance increase, so this job runs most effectively on a single GPU. However, if we come up to 500 Hz for this 18,000 cubic meter hall, without multi-GPU, the simulation takes around 90 minutes, but with multi-GPU, only 58 minutes. So this is a notable performance improvement. If we then go beyond 500 Hz, I think only around 550 or something like that, we are actually out of range for a single GPU. The memory is full, so you can only go up to around 550 Hz or something like that with a single GPU. But here I show going up to 800 and 1200 Hz. And we see, of course, these simulations take longer. This is going quite high in frequency for a very big hall, but it's certainly still doable. And this is something that you could not do before. And you can, of course, leave this running overnight or work on other things while this is running in the cloud. And you can run many simulations in parallel and all that. So this is a very nice improvement regarding the wave-based performance via multi-GPU. Next on the agenda is acceleration of the GA solver. We have essentially rewritten notable parts of both the image source solver, which is for early reflection modeling, and the ray tracing solver, which is for late reflection modeling, so that it performs much faster than before, especially in complex geometries where we see several orders of magnitude in speed up compared to what we had before. So now you can, with Treble, very easily simulate very complex models with geometrical acoustics, which was difficult to do before. And I'm going to show just a couple of comparisons, running side by side, essentially, before and after this performance upgrade. First, sort of a relatively simple model, the one I have on the screen actually right now, where we see sort of a modest performance improvement. And then I'll show a more complex model with a lot of small surfaces, a lot of curved surfaces, and so on. This also reminds me that Treble kind of very much handles curved surfaces very well, so you can have very finely meshed curved surfaces, and all solvers handle that very well.